Welcome back. This is Mrs. Boots, and we're solving systems by elimination. In this case, we're doing our Algebra 2 level systems. So we have 3 by 3. That means 3 variables, 3 equations, just like it did with substitution. Only this time we're going to use elimination. All right, so with elimination, again, I still look for same coefficient, opposite signs. So as I look at example 6, I look at my x's. I have -1, 4, and 1. Okay, so I have one set that's same opposite signs. Okay? Then I look at the y's. I have -5, -5, +5. Okay, so that's the same number, and I've got some opposite signs in there. So that one can definitely work. Now let's look at the z's. -5, 4, and 1. All 3 different. Okay, so z's, we're not even trying to eliminate those. I think y would be the best option. Now, because we have 3 equations, I am going to label them A, B, and C. That way I can keep track of which ones I'm using. Okay? Now, I'm going to look at B and C first, just because they're at the bottom. And so I'm going to write myself a little note. I'm doing B, C. We're not talking about dates. Okay? And I'm just going to add them together because I notice the y's have the same coefficient and the opposite sign. That means they're going to cancel. So I'm going to write that down. I have 4x minus 5y plus 4z equals 19. And then I have x plus 5y minus z equals -20. Okay? We're just going to add them together. We already know the y's cancel. That's the beautiful thing. Okay? Y's are going to cancel. So now let's figure out what's up. I have 4 plus 1, which is 5. So I have 5x, and then 4 minus 1, 3z equals 1, -1. Okay? So now I'm down to 2 variables. That's awesome. So now let's pick 2 different equations and get the y's to cancel for those so that I have 2 equations with 2 variables. So I'm looking, and I used B and C last time, right? All right. So I can't use B and C again. I have to do something else with one of them. So in this case, I'm going to use A and C. Now, why would I pick A and C? Notice the y's are still the same number, opposite sign. Okay? So we're going to go with A and C. I'm going to write those down. So I have -x minus 5y minus 5z equals 2. Positive x plus 5y minus z equals -20. Okay? Add it together. We know the y's are going to cancel. Let's look at the x's. Oh, cool. My x's cancel. That's awesome. Now the z's. I have -5, -1, that's -6, and 2 and -20, that's -18. That's only one variable. That's awesome. Sometimes it works out that way. Not all the time. Now, if it didn't, yeah, we'd have to do a little extra. All right, so let's look at this. It worked out that way. How do I find z? Yeah, we're going to divide by that -6. So that gives us a +3. Okay, so we divided by -6, divided by -6. Here's the cool part. We can now take that +3 and plug it in. Okay, so we're going to take our second equation, which was BC, and we're going to plug it in. So I had 5x minus 3 times z equals -1. And we're going to plug in the 3 that we just got for z. Very, very similar, only now we got to find y and x as well. Okay, so we found z, plugged it in. I got 5x minus 9 equals -1. What do? Yep, we add the 9 to the other side. Okay? Oh, that's +3. Looky there. I knew something wasn't right. Yeah, 4 minus 1, that's +3. Okay. So it's a +3, it's a +9, so when I subtract that, I get, yeah, I get negative 10. Okay? Then we divide by 5, and we get negative 2. So now we have a second part of our answer. We have x and we have z. Now we need to find y. In order to do that, I'm going to go back to one of my original 3 equations. It doesn't matter which one, as long as we use an original equation. Okay, so we'll just pick A. It's on top, it's first, no big deal. So we're going to pick letter A. Okay, so I have negative x, we're going to plug that in, minus 5y, minus 5 times z, plug that in, equals to 2. Safe enough, right? What was z? Z is positive 3. Make sure you put it in the right spot. And what was x? X is negative 2. Okay? So I have a negative of a negative 2. What is that? Yeah, positive 2. So let's just go through and do this. We have 2 minus 5y, negative 5 times 3, negative 15 equals to 2. Okay? So we need to, simplify, combine like terms. That gives us minus 13 equals to 2. Add the 13, I get negative 5y equals to 15. Y equals, because you divided by that negative 5. Negative 3. Okay? So, x is negative 2. Y is negative 3. Z is positive 3. There's my answer. All 3 of them make up the answer. Easy enough, right? Now let's look at example 7. We're going to do the exact same thing. We're going to look at each variable coefficients. Same number, opposite sign. So I look at my x's. Negative 4, negative 2, negative 2. Okay, well 2 of them are the same. Possibility. Y's, negative 5, negative 5, 5. I must love getting rid of y. Why, I don't know, but you know. Z's, I have a 1, a negative 2, a negative 2. So I'm going to go for y's again. It may be different on different problems, and that's okay. Label them A, B, and C. Okay, so we're going to do A and C first, right? We did B and C last time. Let's do A and C this time. Now, why did I pick A and C and not A and B? Yeah, the sign's opposite. I don't have to multiply by anything. This is awesome. Okay, so A, negative 4x minus 5y minus c equals 18. C, negative 2x plus 5y plus 2z equals 4. Okay? Add them together. We already know the y's are going to cancel. That's the beautiful part. Now let's look at everything else. So we get negative 6x plus z equals to 22. No, it really didn't help us that much. That's okay. Let's do B and C now. Why did I pick B and not A and B? Why did I pick B and C? Yep. Same number, opposite sign. That's the goal. If you don't have to multiply, it's easier because then you lower the risk of making a mistake, right? So I'm going to write down B. I have negative 2x minus 5y minus 2z equals 12. Write down C, negative 2x plus 5y plus 2z equals to 4. Add them together. We know the y's cancel. Boom. Now let's look at the x. Negative 2, negative 2, negative 4x. Look at the z's. Oh, gold mine. The z's just canceled. That's awesome. Now 12 plus 4, 16. Isn't this cool? We can just go ahead and solve that. Okay, divide by negative 4. Yeah, 16 divided by negative 4 is negative 4. Not real hard, okay? So now we can plug it in. Well, let's plug it in right here on the AC solution because then we can find Z. So let's do that. So we're going to come up here and plug that in, okay? So I have negative 6 times whatever x is plus z equals to 22. Okay? What was x? X is negative 4. Okay? So we're going to plug that in. Negative 4. So what is negative 6 times negative 4? Yeah, positive 24 plus z equals 22. Now I got to subtract that 24 to get it to the other side, right? So what are we going to get when we subtract it? Very good. We get a negative 2. Let me show that step just in case I've lost anybody. So we go to subtract 24, subtract 24. That's how we get the negative 2. Okay? Well, now I have x and I have z. The only thing I'm missing is the y. So let's take x and z, and we're going to plug them both in up top. You get to pick the equation. It doesn't matter which one you pick. Make sure it's an original. I'm going to pick equation C, just for kicks and giggles. Okay? So I have a negative 2 times my x plus 5y plus 2 times z equals to 4. Okay? Now I'm going to plug in my numbers. Remember, x is negative 4. Z is negative 2. Okay? Now we're just going to simplify. What is negative 2 times negative 4? Yep, positive 8 plus 5y. This gives me a minus 4 equals 4. Okay, simplify. What's 8 minus 4? 4. Very good. We're going to subtract that 4 to the other side. 4 minus 4 is 0. Mrs. Boots, what do we do? Really? Yeah, you guys know you can have no money. It's not any fun, but it's possible. So when we divide by 5, we just get 0. Okay? So we have x is negative 4, y is 0, z is negative 2. Now let's double check. Let's make sure we got this, okay? So we had positive 16, right? Yep. We got our negative 4. Okay, that makes sense. We plug negative 4 in here. We got positive 24, yeah. That gave us a negative 2. We plug in negative 4, negative 2. We got positive 8. We got negative 4. And we got 0. Okay? So it's okay to walk through it again and double check it. And this is the correct answer for example 7. And now we will do our last example, which is a word problem. We got to write the equations and do it. But that's okay. It'll be easy. Hello, this is Mrs. Boots, and this is our last example on solving systems by elimination. And this happens to be a word problem. I know, it's one of your favorites, right? So remember, we go through and we circle the numbers. And I see we have $3, we have $4, we have an 8, we have a $50, and we have a $5. Okay? So let's see if we can figure out what those numbers are talking about. We read the whole problem. Jane sells homemade candles at a local market. She requires $3 of ingredients. Okay, so there's one thing that we have. Ingredients are $3. And that's $3 per candle. All right? So now let's look at the next one. So we have labels cost $4 for a sheet of 8. Okay, so it's $4 per 8 labels. Now, I know this is kind of common sense, but remember, she's only going to use one label on each candle, so she's got a sheet of 8. She's going to use that on 8 candles, all right? Then it says that she has to pay $50 to rent the booth. all right? And she sells them for $5. All right, so I'm going to put that in a separate category. Okay, so we're selling the candles for $5 each. How many candles does she have to sell to break even? So this is the prime example of what I was talking about, where you're going to have a cost and a profit price. And so we have to find the difference. Now our cost has three different pieces, right? So we're going to write an equation for our cost. And we know it's $3 per candle. So that's 3x, right? Because we just want it for one candle. So now, here's the trick for the labels, right? We're going to add, but it's $4 for 8 labels. So we're going to do 4 divided by 8. And that's with an x. So it ends up being, what's 4 divided by 8? A half, right? So what's half a dollar? 50 cents. Okay, so let's just put a little note that this is 4 over 8, which is 50 cents. Okay, so she's paying 50 cents for each label. Then she's got to pay $50 for the booth. Okay, so her cost equation is actually, remember this was 0.5, right? So it ends up being 3.5x plus 50. Now where did we get the 3.5 from? You guys are so good. You've already got it, right? We're going to combine some like terms. So we have those x terms get combined right in there. Okay, now let's look at our price, right? So our price equals $5 per candle. So it's just 5x. Not a big deal. Our profit, what do you think the profit's going to be? Yeah, it's the price minus the cost. But we said break even, right? So break even means our cost equals our price. All right, so we're going to set these two equations equal to each other. Super easy. So our cost was 3.5x plus 50, and our price is 5x. Now all we got to do is solve, and it's really, these are simple ones, right? We're going to subtract that 3.5 to get it to the other side. So if I have $5 and I subtract $3.50, I get, yep, 1.5, okay? And then we divide both sides by 1.5 and we get 33.3. That's how many candles we have to sell to break even. Now, can you sell 0.3 of a candle? No. Okay, you can't say, well, this one's used. You get a discount. All right, I've already used 2/3 of it as a demo. So, no, that doesn't work that way. So we have to round up because you cannot sell 1/3 of a candle. So X is 34. So you have to sell 34 candles before she starts making any profit. She has to sell 34 candles. And that's how a small business person would do this. And so you would actually do this if you have a booth and you're selling candles and necklaces and pocket knives and, leather pouches or whatever else. You would do this analysis for each and every product that you're selling to figure out your break-even point. And then you would also do a profit where you do your cost, your price minus your cost. And so once you break even, you're figuring out what your profit is. So you'll know how much you're going to be making. So you can kind of tell, okay, well, if I'm selling 5 of these a week, that's going to take like a month and a half for me to break even. That's a long time. Okay, so I need to be selling more than 5 a week. So do I have it priced too high? What's going on here? And so that feeds into the business analysis that people perform when they're going out and doing this so that they don't end up in trouble. And this concludes all of our examples for solving systems by elimination.